Hello everyone and welcome. Today I'll talk about longest substring without repeating characters. It's a medium level question. The question provides you a string S, asks you to find the length of the longest substring without repeating characters. So how can we do that? To solve this problem, we will introduce a concept known as sliding window. We use left and right pointers to define the window. The general idea is that while the right pointer keeps traversing to the right, the left pointer is being smart updated to ensure that the window stores only unique characters. As we traverse to the right, sooner or later we'll encounter a character that was last seen before. In this example, this blue S was last seen before in this red S. To avoid duplicates, we want to move the left pointer to the next index of this red S. So we have this T blue S here as defined by the left and right pointer. And then this window keeps expanding to the right. Again, we encounter another character. In this case would be the green S, was last seen before in the blue S. Again, we want to avoid duplicates, so we move the left pointer to the right of this blue S. Here we keep expanding the right end of the window by increasing the right pointer. And sooner or later, we'll encounter another character that was last seen before. In this example, is the purple T, was last seen before in the black T here. Again, we wanted to move the left pointer to the next index of this black T. However, we don't want to move the left pointer backward because the left pointer is already here. If we move to the right of the black T, we will move it one step backward. If we move the left pointer backward, chances are it may incur duplicates. In this example, you will incur a duplicate with this blue S with the green S. Thus, in general, we update left pointer only if it's increasing. And as a result, we keep traversing to the right and increasing the right pointer. Although the purple T, purple N, and purple G were last seen before, but it brings our left pointer backward, thus we do not update our left pointer. And that's how we use the left and right pointers to define the window to store unique characters. Here's a summary of the sliding window technique using left and right pointers. Please feel free to pause the video to read the information here in some more details. Importantly, we use a hash map to keep track of the last seen index and keep track of the global maximum length. And this part, we update left only if it's increasing, may not be very intuitive. A more intuitive but slower version is to use a sliding window technique with string array. Here is a sliding window technique using string array. In general, the idea is that while the right end of the window keeps expanding to the right, the left end of the window is being smart updated to ensure that the window stores only unique characters. So as the right end keeps expanding to the right, sooner or later we encounter a character that was already in the window. To avoid duplicates, we move the left end of the window to the next index of that character within the window. Therefore, we move the left end to the right of this red S here. So our new window is TS, the blue S. And we keep traversing to the right, expanding the right end of the window. And again, we encounter another character, the green S here. That was already in the window. the blue S. To avoid duplicates, again, we move the left end of the window to the right of this blue S. So we keep only UBS here. Here we keep traversing to the right, expanding the right end of the window. Here we encounter a character T here, the purple T. However, unlike in the left and right pointers version of the sliding window technique, this character T is not already in the window. UBS lost. There's no need to adjust the left end of the window here. Because of this property, the string array version of the sliding window technique is more intuitive. However, the string array uses array, a list. Therefore, is computationally less efficient than using a hash map to keep track of the index. Here are the summaries of the sliding window technique using either left and right pointers or string array. Please feel free to pause the video to read the information here in some more details. The major difference is how to update the left end of the window. With the background introduced, now let's write the code. So first of all, we'll use the sliding window technique with the left and the right pointers. For the left pointer initialized to be 0, and we know the right pointer will be index traverse through the string S. So we use enumerate S for this purpose. And then we also initialize the maximum length to be 0. And at each iteration, the maximum length equals the maximum of maximum length and right minus left plus 1. And we also use a hash map to track the index for a character. So hash map character is equal to the index. Now the question is about the left pointer. So we know that if the character is in the hash map, then to avoid duplication, we need to do some adjustment here. So if the index is larger than the currently left pointer, then we have the left pointer equals to that index plus 1. Okay. So to ensure we don't accidentally incur additional duplications. And finally, we will return the maximum length. And that's our code using left and right pointers and the sliding window technique. Now let's test this code to see how it works. We submit, it's pending, it's judging, and done. It's 44 milliseconds, pretty good, both in terms of time complexity and space complexity. Now we will analyze the code for the runtime complexity. For time complexity, we have on, since we use the enumerate to traverse through each character in the string S. For space complexity, is also on. It's about the hash map here. The hash map has the maximum size equals to the size of the string S. If every character in S is unique. So that's all for the solution using sliding window left and right pointers. Now we can also modify the code so it becomes the sliding window technique by using string array. In the string array version, we don't have a left pointer anymore. Instead, we have the string array initialized to be an empty list. And the maximum length is the maximum of the maximum length and the length of this string array. Furthermore, we don't have the right pointer anymore. So we can just iterate through each character in the string S. And then append the string array, append the character at the end. Finally, instead of using hashmap here, we said if the character is in the string array. And then we want to use a substring slicing here. So the string array equals to string array, and the slicing is given by string array index, the character plus 1. Okay, so that's the slicing we're going to use. And then we don't need this part anymore. So that's our code using sliding window technique string array version. And now submit the code to see how it works. We submit, it's pending, judging, and done. Let's see. It's pretty good. The runtime increased a little bit, but this is expected since we use a list lookup instead of a hash map lookup. So the list lookup tend to take a little bit more time. And now we can also analyze the code for complexity. First, for time complexity, it should be between on and on squared, since we use the for loop to iterate through each character in the string S. But we also have this lookup in the list here, as well as this index operation. Secondly, for space complexity, since we use this string array to store the substring, so it's on, since in the worst case scenario is the same length as original string S. And that's all for this question. Hope you find this video to be useful. Please feel free to subscribe for more videos. Hope to see you next time soon, and goodbye.